Hi guys, welcome. And today we're going to talk about magnetism. All right, so we're going to talk about what are the properties of magnetism, how does magnetic fields work, all right, and how are things attracted to a magnet. So what are the patterns we notice? Okay, so magnetism, obviously a magnet is an object that has a property of attracting certain substances to it. So basically, most of them are going to be metal material, I would say, or metal mixtures of some sort. All right, we'll discuss which metals actually attract the magnets in a moment. Magnetism is the force of attraction of some materials to a magnet. All right, so what are the things that attract to a magnet? So obviously, iron comes to mind right away. So iron definitely attracts to a magnet. Most metal materials, so in general, nickel that have nickel, cobalt, and iron are going to be the ones that attract the magnets. Um, Aluminum is a common metal that does not attract to a magnet. However, they can take it and make an alloy out of it. Alloy is a mixture of metals, and that will attract to a magnet. All right, also a magnet attracts other magnets to it, all right, as you guys know. The compass will point also north unless placed near another magnet, right? So if you put this compass needle towards a magnet, the red pointer will point towards the magnet, right? So and you will follow it around the whole magnet if you play around with it. Okay, magnetic materials, mostly metal things, as I mentioned. So paperclip, staples, iron filings, file cabinet, nails, all right, and that's why on construction sites they can actually have the stick with a magnet on the end of it to attract nails. Non-magnetic materials include erasers, wood, paper, chalk, plastic. All those materials, the magnetic field, what we're going to talk about in a moment, passes right through those substances and does not interact with them at all. All right, so they're not magnetically attracted. Okay, magnetic pole is the ends of the magnet where the magnetic force is strongest. And there's a pattern to this. So if you take two magnets and they interact with each other, opposite poles attract. So a north and a south near each other, you'll see they stick together. Okay. The reverse is true for like poles, all right? So similar or like poles repel. So repel means to move apart. And so if you put a north near a north or a south near a south, they'll actually move apart from each other. And you'll actually feel the force. There's actually a pretty strong force pushing them apart. They don't want to be anywhere near each other. So opposites attract. And obviously, this is kind of interesting because sometimes we want things to stick together. Sometimes we want things to kind of float or levitate. So we can use these properties to kind of do that. And we do that with objects occasionally. Okay, the field lines. So the magnetic field is an area around the magnet where the magnetic force is felt. Okay, and obviously where the lines are closer together, that would be the strongest part of the magnetic field, right? So if you notice by the north and south pole, you're going to see lines all concentrated. That's where the magnet is strongest. It's weakest on its sides, all right, because there's less field lines there. The field lines are invisible lines mapping out the magnetic field. So again, we can't see them, but they are there, and that's where the force will be felt from the magnet. The lines leave the North Pole. All right, you notice they're going out of the North Pole and then go towards the South Pole. All right, so you notice that all the lines are going into the South Pole. They never cross or touch, even though it looks like they're touching here. There's actually a little itty bitty space between the particles and the field lines, I should say, not particles. And basically, that's the strength of the strongest part is where they're closest together. Okay, what does the Earth's magnetic field look like? Well, the Earth is one big magnet, all right? There's actually molten material in the center of the Earth moving around, creating the magnetic field. And the South Pole, so Earth actually has a magnet in it technically, like this. what we call the North Pole is actually the South Pole of the magnetic field. And what we call the South Pole is actually the North Pole of the magnet. And what ends up happening is the field lines go out of the South Pole and go towards the North Pole on Earth. And that's why all compass needles point up towards the north, right? That's the way that works. Okay, so you notice it says North Geographic Pole is a South Magnetic Pole, and South Geographic Pole is a North Magnetic Pole. All right, so opposites attract, so once again, that's why our north needle points up towards the North Pole. Okay, and lastly, how do magnetic fields actually interact? So like poles will repel or move apart. You can see the lines going apart from each other, and then opposites attract. You can see the north going to the south. All right, thank you guys for tuning in. That's it, and I'll see you next time.